Welcome to AS Engineering Academy and AS Law Online. This is YV Ramaiah, Faculty of AS Engineering Academy since 2012. Here, how to crack ISRO exam by myself. Here, ISRO series, branch Computer Science and Engineering, subject COA. You should know the importance of the COA subject before writing the ISRO exam. That exam will be conducted on coming 14th September 2025. Before going to start the previous year questions, first you should know the importance and satisfactory things also. Here, it is excellent opportunity to serve our nation, and at the same time, and it provides excellent pay scale also. So not only self-satisfaction, pocket satisfaction is also there. At the same time, how to secure a job in ISRO exam, means how to crack ISRO. Here, as per my observation, most of the previous ISRO questions from our subject, COA subject, are nothing but the previous gate questions. Simply those were copied and pasted. More than 60% previous ISRO questions are nothing but the previous gate questions. That's why if you prepared well for gate exam, that knowledge is enough to crack ISRO exam. Not only this one, for BARC also. Here we are going to concentrate only on ISRO exam. Next, at the same time, look here. Syllabus. This syllabus is almost equal to gate syllabus, but for writing CSE gate, we require the following topics from our subject. These are nothing but machine instructions and addressing modes, ALU, data path and control unit, instruction pipelining, memory hierarchy, cache, main memory and secondary memories, IO interface, interrupt, DMA, computer arithmetic. Along with these topics are needed for writing the gate exam. Along with these topics, basics of 8085 microprocessor and 8086 microprocessor also needed. Here we found so many number of questions, so many number of times from the microprocessor 8085 and 8086. At the same time, look here. Here this exam was conducted during these timings: 2007, 2008, 2009, 2011, 2013, 2014, 2015, 16, in 17 two times. Next, 18, 20, 23 and upcoming exam on 14th September. At the same time, if you watch the different number of questions given in different subjects, DMS, discrete maths, like that. Here, if you watch the COA or CAO, Computer Architecture and Organization, here in 2007, 4 questions, 2008, 13 questions, like that. In total, in all these years, we found the 101 questions in all these subjects. Now, which one is having highest weightage? OS subject is having highest weightage. It has 137 questions only from OS subject. Later, it is having first priority. Next, second priority regarding the number of questions, regarding weightage. In this, computer networks, second priority. Third one, digital circuits. Fourth one, COA. At the same time, as per my knowledge, so many students were not interested to learn the subject while pursuing the BTech degree or any bachelor degree. Here, a student who can able to solve more number of questions from our subject along with the decent performance in other subjects. Along with the decent performance in other subjects, a student who can able to solve more number of questions from COA subject, definitely he can achieve the target. That is the importance and the energy of our subject. At the same time, I am going to provide the weightage of only our subject in year wise. In 2023, if you watch only 2023, these are the weightages of different subjects. At the same time, computer organization, it is having, from this subject we have only 3 questions in 2023 paper, but earlier so many questions were there. These number of questions will be changed from year to year. At the same time, look here, COA weightage, only our subject weightage. 2007, 4 questions, 2008, 13 questions, 2009, 14 questions, 2011, 14 questions, 2013, 8 questions, 2014, 6 questions. Unfortunately, in 2015, only 4 questions. Next, in 2016, 7 questions, nothing but the number of marks what you are going to secure from this subject, nothing but deciding factor, job deciding factor. Next, 2017, 4 questions, 2018, 5 questions, in 2020, 11 questions, 2023, 3 questions. Already I told earlier, I am going to repeat the statement. Those candidates who are going to solve more number of questions from our subject means COA subject, along with the decent performance in other subjects, definitely they can achieve the goal. There is no second doubt in it, because it is the importance and the energy of the same. Next, look here, I am going to start the questions. Here, in this, first I am interested to discuss the 2023 questions. 2023, we had only 3 questions. I am going to provide the explanation for all. First one, in a vectored interrupt, question is over. Options are like this. Here, all are MCQ questions, multiple choice questions, means only one correct answer will be there. At the same time, negative marking is also there, 1/3 negative marking. Now look here. In a vectored interrupt, what is option A? The branch address is assigned to a fixed memory location. The branch address is assigned to a fixed memory location in memory. Next, B, the interrupting source supplies the branch information to the processor. C, the branch address is obtained from the register in the processor. D, none of the same, none of the above. In this, correct answer is option B. If it is vectored interrupt, one separate memory address is allocated for each vectored interrupt. Look here, one separate memory address is allocated or reserved for each vectored interrupt in interrupt vector table, IVT, interrupt vector table. Here, whenever processor received a request from a vector interrupt, the device supplies its address directly to the processor. From where? From IVT. Suppose if it is non-vector interrupt. For all non-vector interrupt, only one fixed address is allocated. That's why after receiving an interrupt signal from non-vector interrupt, processor doesn't know its address, vector address, but after receiving an interrupt request from vectored interrupt, processor gets that address directly from the source, means device. These addresses are permanently stored in the interrupt vector table. Come to second question. That's why first question answer is B. The interrupting source supplies the branch information to the processor through IVT, interrupt vector table. Come here. Second question. Read question carefully. The operation executed on data stored in registers is called. The operation what is going on means what is going to perform on registers is known as macro operation, micro operation, bit operation, byte operation. Nothing but micro operation. If any operation is performed between processing registers, then it is known as micro operation. Micro operation means it is performed between CPU registers, also known as processing registers, micro operation is performed between CPU registers, also known as processing registers. Next, come to next one. Which of the following is false about interrupts? About interrupt, which one of the following is false? Now, option A. Interrupts can be triggered by a hardware or by a software. It is true, it is not false, because processor receives an hardware interrupt through a device. Hardware device like keyboard, mouse, scanner, these are used to provide the hardware interrupt. Next, software interrupt comes from the instruction, example, branch instruction, and RST, restart instruction. At the same time, call instruction is there. It is also one type of interrupt. So, interrupts can be triggered by a hardware or software. Yes, processor can receive the interrupt from either hardware or software. Yes, true. Hardware interrupts may be triggered by sending signal to CPU through a system bus. Yes, whenever hardware device is interested to communicate with the processor, it sends a signal through the bus. Yes, it is also true. But he asked the false statement. Next, software interrupts may be triggered by executing system calls. Yes, different software interrupts are nothing but call instruction, restart instruction in 8085 like that. Next, trap is hardware generated interrupt. It is false. Those students who have studied 8086 processor, they can easily understand trap is there, it is software instruction. So, it is not hardware, it is software. That's why option D is false. Correct option is D. First three statements are true, option D is false. He asked the false statement. Come to next one. Question given in 2007 ISRO. Look here. The principle of locality of reference justifies the use of dash. Here it is simple question, very simple question. Answer is cache memory. Cache memory provides locality reference. Cache memory is the smallest memory. Here, while executing a program, the current executing instructions are stored in cache memory and remaining instructions are stored in main memory. Because of that reason, cache memory provides locality reference. Locally, which instructions are available for the processor, it defines. That's why cache memory provides locality reference. Correct option D. Come to next one. Consider a small two-way set associative cache memory consisting of, watch this one carefully. Once again watch this. Consider a small two-way set associated cache memory consisting of 4 blocks. Number of cache blocks is 4. For choosing the block to be replaced, means for block replacement algorithm, uses the least recently used, means it uses LRU technique. At the same time, associativity, N means associativity to number of cache lines, 4, CL means total number of cache lines present in the cache memory. Next, the number of cache misses for the following sequence of block addresses is, here these are the block addresses. He asked the total number of misses occurred while executing a program. During this program execution, processor requires the block numbers in this order. At the same time, in this you should consider initially all cache lines are empty, means no valid information is there in cache memory. Now, given address sequence is 8, 12, 0, 12, 8. These are nothing but the main memory block numbers. Now, for this, watch this. Look here, associativity is 2, number of cache lines 4. Then you find the number of sets. S is equal to CL by N, means 4 by 2, 2, means it has 2 sets, S0 and S1. Mapping expression is K mod S. K mod S here. What about order, request order? 8, 12, 0, 12, 8. Here in this, it is known as S0, it is known as S1. Each set permits only 2 blocks because associativity is 2. Associativity 2 means one set has only 2 blocks. Now in this, request order is 8, 12, 0, 12, 8. Here, first requested block number is 8. 8 mod 2, remainder 0, means it maps to which one? Set 0. Set 0 initially cache is empty, that's why 8 is mapped here. It is known as compulsory miss. CMP means compulsory miss. He asked the total number of misses. After this, 12 mod 2, it also maps to 12 mod 2, it also maps to same 0, remainder is 0. Here, one set permits 2 blocks at a time, that's why it is nothing but 12. For 12 it is first time, that's why it is compulsory miss. Now, set 0 has been completed. Let's come to next one, 0. 0 mod 2 means again remainder is 0, that's why already set 0 is filled with 8 and 12. But it uses LRU, least recently used replacement algorithm. Processor uses the 12th most recently, 8th least recently, that's why 8 is replaced with 0. So for 0 first time means compulsory miss. Next, after this again 12. Right now set 0 is having 12 and 0. The processor requested 12, already it is there, that's why for 12 it is hit, but it is your responsibility to change the position, means you have to shift the 12th block from here to here because it uses LRU technique. You assume processor will be like this, processor will be at this side, means processor most recently spoke to 12, least recently spoke to 0. Suppose if you do not change the order, mistake may be happen. That's why it is your responsibility to change the position of the same after occurring hit. Next, after this 8 is not there. That's why 0 is replaced with 8. Why? Processor most recently spoke to 12, least recently spoke to 0. That's why it is not compulsory miss. It is conflict miss. Why? It is not first time, second time miss. So he asked the total number of misses. How many hits? Only 1. Total number of misses 4. In these 4, number of compulsory misses 3. Conflict misses 1. That's why total 4. Number of hits is 1. So for this, answer C. Okay, na? Come to next one. The memory address register. The memory address register. In a processor, memory address register is used to hold the instruction address, means program address during fetch cycle, and operand address during execute cycle. During fetch cycle, memory address register is used to hold the address of the current executing instruction. During execute cycle, memory address register is used to hold the address of the operand while performing reading or writing operation. Next, look here. Is a hardware memory device which denotes the location of the current instruction being executed. Next, B is a group of electrical circuit that performs the content of instructions fetched from memory. Next, contains the address of the memory location that is to be read from or stored into. Next, contains a copy of the designated memory location specified by the MER after read or new content of the memory prior to a write. It is false. Come to once again the memory address register. Once again, is a hardware memory device which denotes the location of the current instruction being executed. Is a hardware memory device which denotes the location of the current instruction being executed. Yes. At the same time, group of electrical circuit that performs the content of instructions fetched from the memory. No, it is false. Next, contains the address of the memory location that is to be read from or stored into. It is also correct. Here, A and C both are correct. But all are MCQ questions. Here, some conflict is there, ambiguity is there in the question. Here, both are correct. If you will get mark will be bona fide if you write A and C, because both are same, both are true. Next, come to next one. In which addressing mode the effective address of the operand is generated by adding a constant value to the content of a register. Here, basically, addressing modes are classified into this non-computable addressing mode. Next, computable addressing mode. Non-computable addressing mode means computation is not needed to generate the effective address, but in computable addressing mode, computation is needed to generate the effective address. If you watch the question, in which addressing mode, in which one of the addressing mode, the effective address of the operand is generated by adding a constant value to the content of a register. Means to generate effective address, addition operation is required. In this, find such type of addressing mode, absolute addressing mode. It is also known as memory direct addressing mode. It is non-computable addressing mode because instruction directly supplies the effective address. Indirect mode means if it is a register indirect, register supplies the effective address, no computation is needed because it is also non-computable addressing mode. Next, immediate addressing mode. The immediate operand is directly produced in the register, means it is also non-computable, no effective address is needed for this. Next, indexed addressing mode. Yes, because if it is indexed addressing mode, effective address is nothing but constant. Sometimes constant is also known as offset, and displacement also. It is added to the content of index register. Means it is not non-computable, it is computable addressing modes. So for this question, correct option is D. You can find such type of question. One more question, just look here. We can find one more such type of question, just look here. Look here, 2017 ISRO question. The same question was given in 2011 GATE. This question is also almost equal to the earlier question. Look here. Consider an instruction of the type LW, means load a word. LW means load a word. R1 comma 20 bracket of R2, which during execution reads a 32-bit word from memory and stores it in a 32-bit register R1. The effective address of the memory location is obtained by, it is very important. The effective address of the memory location is obtained by adding a constant 20 and content of R2. Means effective address is nothing but addition of 20 and content of R2. Which one best reflects the source operand? He asked the type of addressing mode. Immediate. In this, it is non-computable addressing mode. Register addressing mode, non-computable. Register indirect addressing mode, non-computable. Here, index addressing mode, computable. For this one also, correct option is D. Index addressing. Okay. Watch this one next. Here, excellent question from basic processor organization. Just only 1 minute time is enough to solve this question. A CPU has 24-bit instructions. Instruction size is 24-bit, means 3 bytes. A program starts at address 300 in decimal. Program starts at the address 300 in decimal. Next, at the same time, which one of the following is legal program counter? All values are in decimal. Program counter is used to hold the address of the next instruction to be fetched. Here, type of memory is not given. When type of memory is not given, you should consider byte addressable memory. It is in default. Byte addressable memory. Means each memory location is used to store only 1 byte, but each instruction size is 3 bytes. Means if we write one instruction I1 here, next address is 303 I2, because each instruction requires 3 memory locations. Because of that reason, what he asked in this question, legal program counter value. Here, you have to increase the value by 3 each and every time, because each instruction code size is 3 bytes. Now in this, we cannot get 400, 500, 700 by adding 3 each and every time for the 300. So legal program counter value is 600. Here logic question it is. Apply logic here. Next, come to next question. Here it is from secondary memory. Secondary memory, excellent question. And the same question was given in earlier GATE, same question. Consider a disk packed with 16 surfaces. number of surfaces is equal to 16, h is equal to 2 power 4. Next, 128 tracks per surface, t is equal to 2 power 7. T means number of tracks present in one surface. H means total number of heads required for the disk. One separate head is needed for each surface. That's why here H represents total number of surfaces present in the hard disk. At the same time, 256 sectors per track. 256 means 2 power 8. 512 bytes of data are stored in a bit serial manner in each sector. B means number of bytes stored in each sector is 512 means 2 power 9 bytes. S means number of sectors present in one track. 250 sectors per track. Next, at the same time, the capacity of the disk pack and the number of bits required to specify a particular sector in the disk are respectively. He asked the data storage capacity and minimum number of bits needed to select one of the sectors, not in a track, one of the sectors in entire hard disk. First, let me complete the data storage capacity. Nothing but H into T into S into B. Here T into S into B tells data storage capacity of one surface capacity into number of such type of surfaces. Here H value 2 power 4, T value 2 power 7, S value 2 power 8, B value 2 power 9 bytes. It is nothing but 2 power 28 bytes. 2 power 28 means 256 megabyte. So, data storage capacity is 256 megabytes. Because of that reason, C and D are false. Correct answer can be A or B. Next, he asked the minimum number of bits needed to select one of the sectors in the entire disk. For this, look here. Addressing, sector addressing. For this, first of all, specify the surface address. Surface address is sometimes known as surface offset. How to compute this one? Log H. Next, hard disk is the collection of surfaces. First find the surface number. Address means it's nothing but a number. Later, surface is the collection of tracks. Then track offset. How to compute? Log T. Next, it gives the track number. Track is the collection of sectors, means sector offset. Offset is also known as address. Log S. Suppose if he asked the byte address, you should write byte number also, but he asked only sector address in the entire disk, means in entire disk you should find the surface number. Means how many surfaces are there? 16, means 4 bits are needed for this. After that, surface is the collection of tracks. In one surface, 128 tracks are there. That's why 7 bits are needed. 7 bits are needed here. In each track, 256 sectors are there. That's why 8 bits are needed here. That's why minimum number of bits needed to address one of the sectors in entire disk is nothing but 4 plus 7, 11 plus 8, 19. So from this, correct option is A. Okay, na? Excellent question it is. Next, come here. Watch this one. This question belongs to overflow, computer arithmetic topic. Watch this one. A processor that has carry, overflow and sign flag bits as part of its program status word. Performs addition of the following two 2's complement numbers. First number is this, second number is this. After the execution of this addition operation, the status of the carry, overflow and sign flags respectively will be nothing. He provided two numbers. Those two numbers are in signed 2's complement notation and size of each number is 8-bit. After completion of addition, he asked the status of the carry flag, overflow flag and sign flag. PSW means program status word, also known as flag register. Here first register content is, means first data is, look here, 0, 1, 0, 0, 1, 1, 0, 1. Second one, 1, 1, 1, 0, 1, 0, 0, 0, not 0, it is 1. Perform addition operation in this 0 with carry 1, 1, 1, 0 with carry 1. Here 1, 0 with carry 1, 0 with carry 1. Data belongs to 2's complement, that's why it is nothing but C out. If these are considered as unsigned, nothing but carry. Carry for unsigned, C out for signed. At the same time, in the sum, in this sum, MSB is allocated for sign, means here S is equal to 0, carry flag is equal to 1. Next, what about next one? Overflow. Here, to detect overflow, we use XOR gate. XOR gate inputs are C in and C out, but here we can simply say overflow doesn't occur because overflow does not occur after adding one positive data and one negative data. It is positive data and it is negative data. Because of that reason, overflow flag is 0, means reset. In which order he asked? Carry. What is carry here? 1. Next, overflow 0, sign flag 0. That's why correct option 1, 0, 0, option B. Watch this. Addition of 4-bit 2's complement binary numbers 1101 and 0100 results in size of each data is 4-bit and data are represented in 2's complement means sign. Here he is going to perform addition of these two numbers. First one 1101, second one 0100. Here perform addition for this. What about this? First find the decimal value. 1, 2, 4, minus 8. When the data are represented in 2's complement, MSB sign is negative, that's why nothing but minus 3, nothing but plus 4. If you perform addition operation, nothing but plus 1. If you want to write plus 1 in signed 2's complement notation, MSB is 0. Here 1, 2, 4, minus 8, nothing but plus 1. In this, what he asked here, he asked overflow condition also. First data belongs to negative, second data belongs to positive, means after adding one positive data and one negative data, no overflow occurs, means here no overflow. Because of that reason, A and D are look here, because of that reason, B and C are false. One minute. No overflow occurs means because of that reason, A and D are false. Correct answer can be B or C. In this, sum is nothing but 0, 1. Because of that reason, correct option is C. Okay. Next. Watch this. Excellent question. Same question was given in IT GATE paper. Earlier, means between 2004 and 2008, there was separate GATE paper for CS and IT branch. From 2009 onwards, both branch students are getting common paper. Watch this. What is the decimal value of the floating point number? What is the decimal value of the floating point number? C1 00000 hexadecimal notation. Assume that 32-bit single precision floating point number. It is nothing but, look here, given data. Here it is IEEE standard 32-bit notation, means single precision. Given data is C1D00000 hexadecimal, means base 16. First, find the binary value of the same. C means 110012, 1 means 0001, D means 13, means 1101, remaining all are zeros until completing the 32-bit. At the same time, it is the 32-bit register. In this, MSB is allocated for sign of the Mantissa. Next 8 bits are used for biased exponent 1, 2, 3, 4, 5, 6, 7, 8. Capital E means biased exponent. Its decimal value 1, 2, 4, 8, 16, 32, 64, 128, means 131, nothing but Mantissa. To find the value, expression is there. Value expression is nothing but -1 whole power s into 1.m into 2 power capital E value minus biasing value. In IEEE single precision, biasing value is 127. It is fixed. In this, from this, look here. Look here. -1 whole power s, s is equal to 1 means it is negative. -1 into something, same thing. 1 point, what is Mantissa here? 10100 into 2 power. Biasing value, here capital E value we computed 131, minus 127 means 4. When you got 0 in place of 4, not needed to consider this one in value computation. That's why to get 0 in that place, you have to shift the decimal point to right for 4-bit position, means 11010.0 into 2 power 0, means not needed to consider this. Now it is the value 1, 2, 4, 8, 16, means minus 26. Correct answer is minus 26. Excellent question from IEEE standards. Look here. In DMA transfer scheme, the transfer scheme other than burst mode, DMA operation can be performed in 3 ways. First one, burst DMA, also known as continuous DMA. Second one, cycle stealing DMA. Third one, interleaved DMA. Here in burst DMA, generally burst DMA technique is used to transfer larger size data. Cycle stealing technique is used to transfer smallest size data. That's why here, other than burst transfer, cycle stealing technique answer should be, there is some ambiguity in options. Stealing means it is not stealing, cycle stealing. Not cycle technique, cycle stealing technique. 1 minute, 1 minute, 1 minute. Watch options carefully. In this, watch all options carefully. Cycle technique, stealing technique, cycle stealing technique. So, correct answer is cycle stealing technique, option C. So, you should read all the options clearly. Next, which logic gate is used to detect overflow in 2's complement arithmetic? XOR gate. Here, XOR gate output represents whether overflow has occurred or not. XOR gate inputs are C in and C out. C in is the carry generated by adding data bits. That bit enters in sign bit position. C out is the carry generated by adding both sign bits. Look here, simply look here. Let it is the first data and it is the second data. Don't care means that can be 0 or 1. It is the first data, it is the second data. After performing addition operation, now it is the sign of the first data, it is the sign of the second data. The bit what is generated here, nothing but C in. The bit what is generated here, nothing but C out. These two are applied for XOR gate. If both are same, no overflow occurs. Both are different, overflow occurs. Look here, this question on memory size expansion. Look here, how many 32K into 1 bit RAM chips are needed to provide a memory space of 256K bytes? In this, first you find the target memory. Target memory means target size, means our target. 256K into 8 bits. Memory space means number of memory registers into storage capacity of one register at the same time. Basic size, basic chip size is 32K into 1 bit. If you want to find the total number of chips, expression is nothing but target size by basic size, means 32K here. 32K, 256K means 8. Here 8 8 64. So our answer is option C, 64. Look here, excellent question. The same question was given in 2015 GATE. Excellent question it is. Watch question carefully. This question is given on pipeline. Watch question carefully. Just only 1 minute time is enough for this. Consider a non-pipeline processor with a clock rate of 2.5 GHz. What is the clock frequency he gave? 2.5 GHz. Then what is clock cycle time? First find the clock cycle time. 1 by 2.5 means 0.4. Giga becomes nanosecond. It is the clock cycle time. And average cycles for 4 instructions of 4 means if it is non-pipelined processor, 4 clock cycles are needed to execute one instruction. Here one clock cycle time is 0.4 nanosecond. The same processor is upgraded to a pipeline processor with 5 stages, but due to the internal pipeline delay, the clock speed is reduced to 2 GHz. Assume that there are no stalls in the pipeline. The speed up achieved in this pipeline processor is dash, nothing. If you want to compute the speed up, non-pipeline time by pipeline time, how to compute the non-pipeline time? Non-pipeline time per one instruction. Already he mentioned 4 clock cycles are needed. Clock cycle time is 0.4 nanosecond. Why? If it is non-pipeline processor, frequency is 2.5 GHz. That's why 4 into 0.4 means 1.6 nanosecond. At the same time, what is TP here? After upgrading the same, frequency is, upgrading means upgrading to pipeline. What is frequency here? 2 gigahertz. When frequency is 2 gigahertz, what about clock cycle time? 0.5 nanosecond. Here, while executing large number of instructions, in this number of instructions is not given. While executing large number of instructions, in this we consider only one clock cycle is enough to complete one instruction. That's why one clock cycle time is 0.5 nanosecond. TP per one instruction is 0.5 nanosecond. Because of that reason, answer is 1.6 by 0.5 means 3.2. Same question was given in 2015 GATE, later 2016 ISRO. Okay, next. Here, some more questions are there on microprocessor 8085. Here I am going to discuss 3-4 such type of questions. Look here. Which interrupt in 8085 microprocessor is unmaskable? Unmaskable means non-maskable. Here, if it is 8085 microprocessor, it has 5 number of hardware interrupts. 5 number of hardware interrupt. What those are? RST 4.5. It is also known as a trap. Only this one is non-maskable, and remaining RST 5.5, 6.5, 7.5, INTR. All these are maskable. What he asked in this, non-maskable, that's why trap. RST 4.5 is also known as trap. Next. Look here. Come to some more points regarding microprocessor. First question, because these are very, very, very important. These are not needed for GATE. Here, first question. Number of address lines for 8085 microprocessor is, directly I am writing the answer, 16. At the same time, second question, these are important questions. Number of data lines for 8086 processor is 16. That's why it is also known as 8086 processor is also known as 16-bit processor. Why it is known as 16-bit processor? Data bus size is 16-bit, and at the same time ALU size also 16-bit. And one more question. The maximum memory space permitted by (8085) microprocessor is dash. In this 8085 microprocessor is having 16 address lines and 8 data lines. That's why 2 power 16 memory registers. Each register can store 8-bit. It is nothing but 64K into 8-bit means 1 byte. Simply, its maximum memory storage capacity is 64 kilobyte. Now look here. Our ACE Academy provides, along with offline coaching, online modules also there. Here, self-paced program, means recorded videos will be given. At the same time, online program is also there. If you are having sufficient time, better to purchase the full-fledged videos. If you don't have sufficient time, better to purchase the QRC, means quick revision course. So according to the availability of the time span, go through this. If you consume the either video lectures or physical attendance for our academy, there are more number of chances, more than 99% chance to achieve the goal. And finally, best of luck. Thank you very much.